Assalamualaikum and good day everyone. Today we will continue our chapter 4.3 representing graph and the graph isomorphism. In the previous class we learned about the representing graph. So today we learn about the graph isomorphism. At the end of this video you should be able to show that the two graphs are isomorphic or not isomorphic. Isomorphism of the graph. What's meant by isomorphism of the graph? There are two simple graphs G1 and G2 are isomorphic if there is a one-to-one and onto function or called as the bijection F from V1 and the V2 with the property that A and B are adjacent in G1 if and only if FA and FB are adjacent to G2 for all A and B in the V2. F is called as isomorphism. When G1 and G2 are isomorphic, there is one-to-one corresponding between vertices of the two graphs that are preserve the adjacency relationship. And the isomorphism of simple graph is an equivalent relation. To check whether the graph is isomorphism or not, we have three ways. The first one is the adjacency relationship table. Second is the adjacency matrix. And the third one is simple circuit. Okay, let's see the adjacency relationship table. This is the step that involved in the adjacency relationship table. Okay, there are 4 steps involved, and we need to satisfy all the steps so that the graph is conclude as the isomorphic. So let's see the step 1. We have two simple graphs G1 and G2. So the step 1, we need to find total number of vertices. Okay. We need to specify that the total number of vertices in the graph 1 is equal to the graph 2. And the total number of edges in the graph 1 is equal to the total number of edges in the graph 2. If this is not satisfied, then we can stop here and then conclude that graph G1 and G2 are not isomorphic. If this step is satisfied, then we move to the next step, step 2. The step 2 is the corresponding vertices in G1 and G2 will have the same degree. That means that we need to find all the degree in vertices in the graph 1 and also in the graph 2. The degree of vertices in the graph 1 is equal to the degree all the vertices in the graph 2. If this is satisfied, then we move to the step 3. In the step 3, we mapping the point from the graph 1 into the point the graph 2. Before we maps, we need to ensure that the degree of the adjacent point must have the same degree in the graph 2. Okay, for the step 4, we draw the adjacency relationship table. We have 3 columns here. The first column is list all the edges in the graph 1, and the second column is based on the step 3, and the third column is we see whether the point in the step 3 is have in the graph 2. Okay, let's see the example. We have graph 1 and graph 2 here. So this is the solution for the example 1. This is the summary of the solution in the for the example 1. To make it clear, let's see step by step of the solution. Let's see the step 1. We need to find the total number of vertices and total number of edges. So we see here in the graph 1, we have the total number of vertices is 4, and the graph 2 is also 4. So the total number of vertices in the graph 1 is equal to the graph 2. And the total number of edges in the graph 1, we have 1, 2, 3, 4, 5. So the total number of edges in the graph 2 also we have 5 here. So the total number of edges of graph 1 is equal to the graph 2. So the step 1 is satisfied, so we can move to the step 2. For the step 2, we need to find all the degree for all the vertices that have in the graph 1 and the graph 2. So we can see here that the degree in the graph 1 we have 2, 3, 3, 2. So in the graph 2 also we have 2, 3, 3, 2. So this is equivalent. So the step 2 is satisfied. Let's see the step 3. We map point from G1 into the point at G2. Okay, let's see here. We have the point A with the degree 2. So we need to see the point at the... So we need to see at the graph 2 where the point that also have the degree 2. So we have the... Let's see, we have the point U. We also have the degree 2. And in the graph 1, we see that the point A is adjacent to the B and to the C. A is adjacent to the B with the degree 3, and A also adjacent to the C with the also degree 3. So we need to find that in the graph 2 that have the point with the degree 2 and also have the adjacent with the degree 3. So we have the point U here, and it has adjacent to point V that have degree 3, and also it has adjacent to point W that also have the degree 3. So this is acceptable. So the FA is equal to U. So for the FB, we need to see the point B. Point B is adjacent to the degree 3, degree 2, and the degree 2. So we need to find the point with the degree 3 first. So we have here degree 3. So it need to adjacent to the point with the degree 3, degree 2, and the degree 2. So we have the point V here in the graph 2. So the FB is equal to the V. This is for the rest. And for the step 4, we need to draw the table of the adjacency relationship. We see here that the adjacency relationship here, we have the 3 column, and the first column is about the xy in E1. So we need to list all the edges in the graph 1. So we have the edges A to B, A to C, and B to A. So B to A, we do not need to write it down since this is undirected graph. So B to A is equal to A to B, B to C, and B to D, and also the C to D. Okay, the second column is we see that here is xy in E1. So here is fx and fy. So we have here is A, point A, B. So in the second column we have FA and FV. So we can see that in the step 3, based on the step 3, we have the FA is equal to U, FB is equal to V. So we can just have FA, FB is equal to U, V. So for the rest is the same. So for the third column, we can see here that whether the point here UV in the column 2 point UV, whether it has in the graph 2. So we can see here that point UV, we have the edge that connecting from the point U to V. So yes. So we need to write the yes. So let's see for the UV, UW. So UW, we have U to W. We have an edge that connecting from point U to W. So the answer is yes. If the answer all is yes, so that means that the step 4 is satisfied. If all the step is satisfied, then we can conclude that the graph G1 and G2 are isomorphic. The important part is for you to conclude whether the graph is isomorphic or not. Okay, let's see the example number 2. Example number 2, the step is the same, but we can see here that the example number 2 is not isomorphic, since the degree A is equal to U in the G1, and A must be corresponding either in the point T, U, X or Y in G2, since the degree for them is also 2. However, each of these two vertices is adjacent to another vertex of degree 2, which is not true. So that means that the point A here with the degree 2 need to be adjacent to the point B that have degree 3 and point D that have degree 3. So we have in the graph 2, we have point T here, point T with the degree 2 adjacent with the degree 3, true, and the another is with the degree 2, so it's not true, so it cannot be isomorphic. So this not satisfy the not satisfied, so we need to stop, and then we conclude that the graph G1 and G2 are not isomorphic. So let's see the isomorphism by adjacency metric. For the adjacency metric, the step is also same with the adjacency relationship table, but the difference is in the last step 4. In the step 4, for the adjacency metric, we need to find the adjacency metric of the graph 1, and we also need to find the adjacency metric of the graph 2. And lastly, we just conclude that the graph 1 and graph 2 are isomorphic or not. Okay, this is the exercise 4.3.6 for you. So that's all for today. Thank you.